Hello everyone, Bill Nye here, and I'm excited to welcome you to a fascinating journey into the world of weather. Whether you're a weather enthusiast or just someone who wants to know if you'll need an extra sweater this season, you're in the right place. Today is November 17th, 2025. As the days grow shorter and the air gets crisp, people all across Europe are bundling up and bracing for the winter ahead. But this year, there's a big conversation happening about a weather pattern you might have heard of: La Niña. Maybe you've caught the term on the news or overheard it in a cafe, but what does La Niña really mean for us, especially here in Europe? Is it just another buzzword, or does it have real effects on our daily lives? La Niña is more than just a name. It's a powerful force brewing in the vast Pacific Ocean, capable of shifting weather patterns across the entire globe. It's like a hidden hand, stirring the atmosphere and sending ripples that reach far beyond the ocean's edge. Imagine it as a giant engine deep in the ocean, quietly influencing whether you'll be reaching for a thick winter coat, an umbrella, or maybe even sunglasses this winter. Its effects can be dramatic, changing the way we experience the season. In this episode, we'll dive into what La Niña is, how it works, and most importantly, what it could mean for Europe as we head into the colder months. We'll connect the dots between distant ocean currents and the weather right outside your window. The science behind La Niña reveals just how interconnected our world truly is. A shift in the Pacific can set off a chain reaction, leading to changes in temperature, rainfall, and even storm patterns thousands of miles away. Don't worry if you're not a meteorologist. We'll break down the complex science into simple, easy-to-understand pieces. By the end, you'll be able to talk about La Niña with confidence, no advanced degree required. So, what's in store for Europe this winter? Will it be colder, drier, or wetter than usual? Could we see more snow, or will rain dominate the forecast? These are the questions we'll tackle together. By looking at clues from past La Niña years and analyzing historical weather data, we can make educated predictions about what the season ahead might bring. History often leaves us hints, and science helps us read them. Our goal is simple: to empower you with knowledge so you can prepare for whatever winter has in store. Whether you're planning a holiday trip, getting your home ready, or just picking out your wardrobe, you'll be ready. So, let's dive into the fascinating world of La Niña and discover how this chilly greeting from the Pacific could shape life in Europe in 2025. Stay tuned. There's a lot to uncover. So, what exactly is La Niña? You might have heard the term on the news, especially when talking about unusual weather, but what does it really mean, and why does it matter for people all around the globe, including right here in Europe? La Niña is the cool phase of a natural climate pattern called the El Niño Southern Oscillation, or ENSO for short. This pattern is one of the most important drivers of year-to-year climate variability on Earth, influencing weather, ocean conditions, and even the risk of wildfires and droughts. Imagine ENSO as a giant seesaw stretching across the tropical Pacific Ocean. On one end, you have El Niño, which brings warmer waters and different weather patterns. On the other end sits La Niña, with cooler waters and its own set of global impacts. In between, there's a neutral phase, when things are more balanced. La Niña begins when surface waters near the equator, just off the coast of South America, become much colder than usual. This isn't just a small patch of cold water, it can stretch for thousands of kilometers across the Pacific. What causes this? Strong trade winds, steady winds that blow from east to west, push the warm surface water away from South America toward Asia. As the warm water moves, it allows colder, deeper water to rise up to the surface in a process called upwelling. This upwelling is crucial, as it brings nutrients to the surface and supports marine life, but it also cools the ocean dramatically. During La Niña, these trade winds become even more powerful, intensifying the upwelling and expanding the area of cold water in the Pacific. The result is a vast, chilly patch of ocean that can last for months, sometimes even years. Just a few degrees difference in ocean temperature across such a massive area is like adjusting the planet's thermostat. It might not sound like much, but it's enough to shift weather patterns all over the world. The ocean and atmosphere are in constant conversation. When the ocean cools, it chills the air above, which changes air pressure and wind patterns, not just locally, but across continents and oceans. These changes ripple outward, affecting rainfall, storms, and even temperatures far from the Pacific. La Niña isn't a single storm or a quick event, it's a long-lasting climate condition that can persist for 9 months or more, usually reaching its peak during the northern hemisphere's winter. Its effects can be felt for seasons at a time. Think of La Niña as the cool, windy sibling to El Niño. While El Niño tends to bring warmer, wetter conditions to some regions, La Niña often brings cooler, drier, and windier weather to others. Understanding how these stronger trade winds lead to colder water is key to grasping how La Niña can influence weather patterns, agriculture, and even economies around the world. Even though the heart of La Niña is thousands of miles away in the Pacific, its effects can reach Europe, shaping our winters, influencing storms, and reminding us just how connected our planet's climate truly is. Now that we know what La Niña is, let's talk about its global reach. How does cold water in the Pacific change weather on other continents? It's all about teleconnections, ripples in the atmosphere. La Niña shifts jet streams, those fast-moving rivers of air that steer storms around the globe. In North America, the Pacific jet stream often shifts north, bringing wetter, colder weather to the Pacific Northwest and drier, warmer conditions to the south. In the Western Pacific, places like Indonesia and Australia get more rain and flooding. Meanwhile, Southeast Asia, Africa, and South America see their own unique shifts. It's a global reshuffling. One region's drought can be linked to another's flood. These changes impact agriculture, water supplies, and energy demand worldwide. And the domino effect doesn't stop there. It eventually reaches Europe too. So, how does La Niña in the Pacific affect Europe? The connection is subtle, involving a series of atmospheric handoffs. The main pathway is through the North Atlantic Oscillation, or NAO, a climate pattern based on pressure differences between the Icelandic low and Azores high. La Niña tends to push the NAO into its negative phase, weakening the pressure gradient. This weakens the Atlantic jet stream, making it wavier and less direct. A wavy jet stream blocks mild Atlantic air, allowing cold Arctic air to move into Europe. This is how a La Niña winter can turn colder and snowier for much of the continent. It's a long-distance chain. Cold Pacific water leads to a wavy Atlantic jet stream, opening the door for Arctic air in Europe. What does this mean for Europe's winter in 2025? Expect a tale of two halves. Northern Europe is likely to see a colder, drier winter, while southern Europe could be wetter and milder. For the north, Scandinavia, the UK, Germany, Poland, blocking highs mean fewer Atlantic storms and more cold air from the east. This could bring more frost, snow, and freezing temperatures. In the south, Spain, Italy, Greece, the wavy jet stream steers storms their way, bringing more rain and unsettled weather. The effects often build through the season, with the coldest, snowiest weather more likely in late January and February. So, winter could start mild but turn much colder as the season progresses. Staying updated on forecasts will be crucial. To predict what this winter might bring, it's helpful to look back at previous La Niña years and see how they shaped Europe's weather. By studying the patterns and outcomes from the past, meteorologists can better understand what to expect when La Niña returns. These historical records offer valuable clues, showing us how the atmosphere has responded before and helping us prepare for what could be ahead. For example, the winter of 2010-2011 stands out as a dramatic case. That season brought severe cold and heavy snow to the UK and much of Europe, a classic signature of La Niña's influence. Cities that rarely see deep snow were transformed, and daily life was disrupted for millions. December 2010 was the UK's coldest December in over a century. Major transport networks ground to a halt, with airports and train stations facing widespread delays and cancellations. Roads became treacherous, and communities struggled to cope with the relentless snowfall and icy conditions. Another notable La Niña winter, 2000-2001, also saw colder than average temperatures across northern Europe. People bundled up against biting winds, and cities from Oslo to Stockholm experienced longer stretches of snow and ice than usual. These examples highlight how La Niña winters can increase the odds of so-called blocking patterns, atmospheric setups that allow frigid Arctic air to spill southward, flooding Europe with cold and snow for weeks at a time. However, it's important to remember that not every La Niña winter turns Europe into a frozen landscape. Some years the cold is less intense, and snow is patchy or short-lived. Take 2017-2018 for instance. That year, a weak La Niña was in place. While most of the winter was relatively mild, a sudden shift brought the infamous beast from the east late in the season, unleashing blizzards and bitter cold across Europe. But overall, the winter wasn't consistently harsh. Other factors, like the strength and position of the polar vortex, also play a crucial role in shaping Europe's winter weather. The interplay between La Niña and these other atmospheric forces can lead to very different outcomes from year to year. In essence, La Niña loads the dice in favor of a colder, snowier winter, but it doesn't guarantee it. The final outcome depends on a mix of global and regional weather patterns, making each winter unique. By looking at history, we gain insight into the probabilities, not certainties. Past La Niña, winters help us prepare for what might come, but nature always keeps a few surprises in store. Let's zoom in on Northern Europe, where La Niña's chill is most likely to be felt. Countries like Norway, Sweden, Finland, Denmark, the UK, and Ireland could see a colder, drier winter. High-pressure blocks near Greenland or Scandinavia prevent mild Atlantic air from reaching the region. Instead, cold, dry air from the Arctic or Siberia dominates, bringing more snow and longer-lasting snow cover. The UK and Ireland may see more major snow events, especially in the east. While not guaranteed, the risk of disruptive cold, snaps, and snowstorms is higher. Residents should prepare for travel disruptions and increased heating needs. It's not a snowpocalypse, but a return to a classic cold winter. In Central and Southern Europe, the forecast is more complex. Central Europe, Germany, Poland, Austria, Switzerland, sits between cold northern air and milder, wetter southern air, leading to swings between snow and rain. The exact position of the jet stream will determine whether these areas get freezing temperatures or milder spells. The Alps often shield southern regions from the worst cold. Further south, Spain, Portugal, Italy, and Greece are likely to see wetter than average, stormy winters. Temperatures may stay near or above average, but persistent rain could bring flooding risks. This north-south split is a hallmark of La Niña winters. One pattern, but very different impacts across Europe. We've followed La Niña's journey from the Pacific to Europe, seeing how it can shape the winter ahead. This natural cycle raises the odds for a colder, snowier winter in the north and a wetter one in the south. The forecast isn't a guarantee, but it helps us prepare. City planners, energy companies, farmers, and all of us can use this knowledge to get ready. As winter unfolds, meteorologists will track La Niña's strength and the jet stream's path to refine forecasts. Understanding these forces makes us more resilient. In a changing climate, knowing how natural cycles like La Niña work is more important than ever. It helps us separate long-term climate change from short-term variability. So how can we use this knowledge to better prepare our communities for the future? Thanks for joining me. Stay curious.